Number 1 asks us to find the z-score for a temperature of 71 degrees. Okay, so we know that for a z-score, here's the formula we're going to use, value minus mean over the standard deviation. So if you read the problem, if they want us to find the z-score for a temperature of 71 degrees, 71 is what we're going to use for the value, so I'm going to plug that right up on top here. And then minus, as you read through the problem, it did say the average temperature is 74 degrees. So average is another word for mean. And they also tell us that the standard deviation is 4 degrees. So I'm going to put that over 4. So since 71 minus 74 is negative 3, we could either leave our answer as negative 3/4, or usually z-score we write as a decimal, but either way is fine. So I'm going to say this is equal to negative 0.75. Okay, and again, if you wanted to use negative 3/4, that's fine as well. Number 2 says, a survey asked a group of high school students about the number of hours of sleep they received in a 24-hour period. The data was normally distributed with the mean of 7 hours and a standard deviation of 1.25 hours. Okay, so letter A says, if Harrison slept 8.5 hours, what percent of the students in the survey slept less than Harrison? All right, so the first thing we're going to have to do is we're going to have to find the z-score associated with this value. And, our formula for z-score is right here. So let's go ahead and do this. So we know that the z-score is equal to the value, which in this case, since Harrison slept 8.5 hours, that's the value that we're looking at, minus the mean, which when we read the problem, we look back and it says the mean was 7. And we're going to divide that by the standard deviation, which they told us was 1.25. All right, so you can figure out what this is equal to. 8.5 minus 7 is 1.5. And if you take that and divide it by 1.25, it gives you 1.2. Now, if we want to figure out what percent of the students slept less than Harrison, keep in mind when we do less than, when we go to normal CDF in our calculator, less than tells us we're going to start at a very, very small value, right? Negative infinity. We usually use negative 999, and then we go up until our z-score. So in your calculator, when you go to normal cumulative density function, CDF, you're going to start at a very small value, right? Negative infinity. So we just use negative 9999, and we're going to go up into our z-score of 1.2. All right, so you can do this in your calculator. You could tell it to calculate, and when you do, you'll see it gives you approximately 0.8849. Now, they didn't say what to round to here, but I'm just going to change this to a percent, and when we move the decimal place over twice, we get approximately 88.49%. Okay, so if they don't say what to round to, you can kind of take a look at the numbers and decide. I think, rounding to the nearest hundredth of a percent is always a pretty good bet there. All right, so now letter B kind of wants us to do the same thing, but it says if your math teacher slept 7.25 hours, what percent of the students in the survey slept more than the teacher? Okay, so first thing we're going to do is we're going to find the z-score again. This time, the value is going to be 7.25 because that's the time that the teacher slept. The mean is still going to be 7. And the standard deviation is still going to be 1.25. So when we simplify this fraction, it gives us 0.25 over 1.25, which does simplify to 0.2. All right, now this time when we go to normal CDF in our calculator, since we want to know what percent of the students slept more than the teacher, more than tells us that we want to start at the teacher's z-score, and we want to go all the way up to infinity, a really big number. So we usually use positive 9999. All right, so in your calculator, when you go to normal CDF, the teacher's z-score, or the z-score associated with the amount of time the teacher sleeps is 0.2. And we're going to go all the way up to a really big number. Okay? So this time when we do this, our calculator is going to give us 0.4207. So if we want to change that again to a percent, that would be 42.07%. Number 3 also deals with z-scores. They want to know how many students in the class can be expected to receive a score between 82, and 90. So what we have to do is we have to find the z-score that goes along with a score of 82, and then the z-score that goes along with a score of 90. So first, let's figure out the one that goes along with a value of 82. All right, they tell us the mean is 72.3, and they tell us the standard deviation is 8.9. Okay, so once you subtract the numerators and then divide that answer by 8.9, you should be getting approximately 1.0899. All right, now if we want to find the z-score that goes along with a value of 90, just replace the word value this time for 90, and everything else is going to be the same. So the mean is still 72.3, and the standard deviation is still 8.9, and this time when you subtract the numerators and then divide by 8.9, you get approximately 1.9888. So if we want to know how many students can be expected to receive a score between 82 and 90, let's first figure out what percent of the students score between 82 and 90. So when we go to normal CDF, the lower bound is going to be the z-score that goes along with the lower number of 82. And the upper bound is going to be the number that goes along with the higher score of 90. All right, so when I did that in my calculator, I got approximately 0.1145. So what that means is approximately 11.45% of the students will score between an 82 and a 90. But this question wants to know how many of the students. So since there's 184 students, what we can do is we can take 11.45% of the 184 students, right? Just tells us to multiply those. And when you do, you get 21.068. But we can't have a decimal of a student. So we can say that 21 students, right? If you round that to the nearest whole number, 21 students would be expected to score between an 82 and a 90. Number 4 just wants to know what type of study best describes the situation given. Now, I'm going to first just rule out a survey and a census here. A survey is really just when, people are asked a question or a series of questions in order to gather information about something, so that's definitely not happening here. A census is really just an official count or survey of a population, which also is not what's occurring here. Now, the reason this is an experiment instead of an observational study is because with an observational study, the investigators are not allowed to assign treatments to the subjects. They're just kind of observing them and studying them. So that's not what's happening here. This is an experiment because the doctor wanted to determine the effectiveness of a new nasal spray, so he separated them into 2 groups in which one of the groups was prescribed the treatment of the nasal spray. So this is an experiment. Number 5 just wants to know which population would provide the most unbiased response. Well, letters A, B, and D would all prevent a biased or an unfair response because they focus on a specific population of people. In Part A, they're looking just at senior citizens. In Part B, they're looking at just the people who belong to the Lower Taxes Coalition group. And then in letter D, they're belonging to people who belong to the Snowmobile Club. So letter C is the only one that would provide an unbiased response because they're just randomly picking every 9th person over the age of 18, just walking through the center of town. So that provides a nice variety of people. Number 6 also wants us to take a look at which would be the least biased. Letter A is biased because if you're asking members of a basketball team what's the most watched sporting event on TV, they may be a little bit biased towards their sport. Letter B, if you're asking people at a coffee shop to determine the most popular beverage, everyone who's leaving there probably likes coffee if that's what they're getting. So that would probably produce a biased result as well. Letter C, if you're asking people leaving a movie theater to determine the most popular date night out, well, going to a movie is a date night out. So that may also create a little bit of a bias. So I would have to say letter D here would be our answer. because people leaving the mall and the most popular make of car have nothing to do with each other. So it's not like, they're kind of going to be biased towards one type of car. Number 7 wants us in part A to find the margin of error with a confidence level of 95%. All right, so we're going to be using our formula right here when we have a confidence level of 95%. So the margin of error is going to be equal to 2 times the square root. Now, P is just the proportion of successes, and they tell us that the mean proportion is 0.28, so we're going to plug in 0.28 for P. And then Q would just be really 1 minus 0.28, which is 0.72. And we're going to divide that by N, which is really just your sample size, and they tell us that is 50. Okay, so you can just plug that right in the calculator, and I'm just going to round to 2 decimal places here, and I wind up with 0.13. All right, so part B wants us to find the 95% confidence interval. So in order to do that, all you have to do is take the mean and add and subtract the margin of error. Okay, so if we did 0.28 minus 0.13, that gives us 0.15. And if we did 0.28 plus 0.13, that's going to give us 0.41. So the interval we're looking at here, if we want a 95% confidence interval, is going to range from 0.15 all the way up to 0.41. So number 8 wants us to find the confidence interval if we're given a 95% confidence level. So this is similar to number 7, but first thing we have to do is we have to find the margin of error. And we have 2 formulas we can use. We can either use this formula or this formula. So in number 7, we had used our first formula because they had given us our sampling mean proportion, P. But in number 8, they actually give us the standard deviation, which is this S right here, and they also give us the sample size, which is N. So we're going to use this formula right here. All right, so I'm going to go ahead and do that over here. So we could say the margin of error is equal to 2 times. When you read the problem, they tell you that the standard deviation is 10,000, so I'm going to plug that in, and they tell us that our sample size is 35 people. So when you plug that in the calculator, because we're dealing with money here, we're talking about the average starting salary of college students who have taken a statistics course, I'm going to just take this value and round it to the nearest cent. Okay, a lot of times with money, that's your best bet, rounding to the nearest 2 decimal places, the nearest cent. All right, so if we want to find the confidence interval, all we have to do is take the mean starting salary, which is $55,000, put a little dollar sign in front of that, $785, and I'm going to add on as well as subtract off the margin of error. Okay, so when I do the mean minus the margin of error, I wind up getting the lower bound of my interval to be $52,404.38. And then when I do my mean plus my margin of error, I get the upper bound of this interval to be $59,165.62. So this right here is my confidence interval if I want to be 95% confident.